Hello everyone, and welcome to Performance Testing Tools in Android. My name is Rebecca Franks, and I'm an Android developer at DBT, currently based at DSTV, and I'm a Google Developer Expert in Android. You can find me blogging at rigaroo.co.za and on Twitter at rigaroo. If you want to follow the slides on your own, I've just probably tweeted a link to it, so you can check it out soon on my Twitter. It should be out soon. So let's get into it. Okay, so the things that we're going to have a look at today is what actually went wrong. And then we're going to have a look at different types of performance issues. Then we're going to have a look at analyzing these issues, so using things such as rendering analysis, memory analysis, compute analysis, and battery analysis. Cool. So what went wrong, right? You're building up an Android app. It's a very difficult task. And once you've wrapped your head around layouts, activity life cycles, and threads, it's a whole thing that you have to think about. And you're probably pretty chuffed with yourself. If you've got an app on the store, you think, great, I've made a good success. You release your app into the wild, and people start to download it. When all of a sudden, you start to see 1-star reviews. People are angry, they're irritated, and they hate your app. They're saying it's frustrating, laggy, and it's very slow. So this is probably the first sign of your app actually having a performance issue, if you didn't already notice before the app reviews. Unfortunately, waiting until the app reviews to come out is more of a reactive way, where we should probably be a bit more proactive throughout our development lifecycle. So if you aren't aware of the problems, though, that exist, you won't know how to really prevent them in the future. So we're going to have a look at the different types of performance issues. So performance is a big encompassing word, which means a lot of actual things. It can mean anything from how your app responds to the user or anything that makes your user get irritated with it. So I'll highlight a few of the issues, but you should note that this list isn't exclusive, and there's a couple others that are also are performance issues. So we'll just highlight the top ones that you should look out for. The first error that you should look out for is an ANR, the application is not responding. So I'm sure everyone with an Android phone has seen this dialogue at least once, even if it's not from your own app. So what does this mean, though? It means that your app is doing way too much work on the main thread, and it can't do anything more, and it can't process any more frames. So it's locked up, and it's waiting for your processing to finish. Examples of when this would happen is if you're reading from a file on the main thread, or you're doing a long-running operation on the main thread. The next issue that we're going to have a look at is an out-of-memory error. So this will come typically in the form where you'll get app crashes coming through, maybe from the store, or maybe like a random one that happens that you can't reproduce. And this would typically be what your stack trace would look like. So what does this mean, though? It means somewhere in your app you have a memory leak, actually. And the device literally has no more memory to store anything. And it's holding onto that memory, and it can't actually be garbage collected. So we'll take a look at those too. The next performance issue that we're going to have a look at is drop frames, stuttering, and slow animations. Now this is probably the most difficult to fix. And it's really tough. And this is caused when your app can't meet the 16 millisecond time to draw one frame onto the screen. So why 16 milliseconds, you may ask? So this is basically how long you get to draw your frame. And if you take 60 frames per second is what your app needs to be drawing at. So 60 frames per second, if you take 1 second and you divide it by 60, you'll land up with 16 milliseconds. So that is the amount of time that you get to draw one frame in the app. And if you're doing any long-running operations that take more than that time, that's when you'll get drop frames happening. So this is something that you need to be aware of and remember throughout the rest of the slides. Cool. The last performance issue that we're going to have a look at is draining a user's battery. So this is quite a common occurrence, and it's quite obvious as to what it means. But basically, your app is doing too much work and way too often. So right now we've established what kinds of different performance issues there are. So how do we go about fixing them? So the first set of tools that we're going to have a look at is ones that analyze your rendering time. So this is typically things like your actual display to the user. The first tool that we're going to look at is GPU Overdraw. So what is overdraw actually? So it's the number of times your screen has been redrawn on top of one another. So you should probably try reducing this, and you'll improve your drop frame rate as it won't happen as often. When you enable the tool, you'll see a bunch of different colors on the screen. And if you see the little section over there, it highlights exactly, if you have no overdraw, it means you'll see the true color on the screen. If you have 1 times overdraw, you'll see blue, 2 times you'll see green, 3 times you'll see pink, and 4 times you'll see a darker red. So how do I actually go about enabling this tool? So you go into your phone on your developer options, and you select Debug GPU Overdraw, and you select Show Overdraw Areas. Your screen will turn all the different colors, and you'll start to see how much rendering your app is actually doing. So you can see in the screenshot on the right, my app was actually doing quite a bit of overdraw, and the images were really, really red. So how did I actually improve this? By simply removing the background that was defined on my linear layout, I was able to reduce the overdraw immensely. And you can see I actually just took advantage of the Android systems background that I set. And then I reduced the overdraw, literally by removing one color. So this kind of small optimization often is all it takes to improve your layout. And other reasons for your overdraw could be that you have a very deep layout hierarchy, which is what we're going to have a look at next. So Hierarchy Viewer is the next tool we're looking at, and this tool visualizes your app's view hierarchy and lays it out nicely for you to see. Each step in your hierarchy adds time for drawing onto the frame. So your goal should be to reduce the number of times you're going deeper into your hierarchy. So let's take a look at how to use it. So in Android Studio, you're going to select the Android device monitor, and this will start up a separate tool. And then you will select Hierarchy Viewer from the top. You'll then select the layout that you want to look at, your activity, and then it will start to render exactly what's happening on your screen. So you can see my layout hierarchy is actually very deep, which is not a good sign. You can also click on a view in the hierarchy, and you can also then profile how long it takes to render that. So if you click on that red, those 3 dots at the top, you'll see it starts to actually put dots onto each little layout. So these dots mean different things. The first dot is how long it took to measure the layout. The second dot is how long it took to draw your layout, and the third is how long it took to actually lay it out. Okay? So if it's red, means bad, you should probably look at improving it. But yeah, so that's what the hierarchy of the tool can do. It can do a whole bunch of other things, such as viewing screenshots of exactly the section that you're looking at. It can also export your view into a PSD file, so you can actually view the layers of your hierarchy. So you can see in my layout, I've probably got a few too many. I could probably remove that linear layout as it's doing not really very much, and I would actually reduce the hierarchy over there. So that's hierarchy tool. There's a couple of other things you can do around it, but that's generally what it gives you. So the next tool that we're going to have a look at is Profile GPU Rendering. So this gives you a quick visualization of how much time it's taking to actually render out your frames. So it's good for seeing if your app is meeting the 60 millisecond frame mark, and if it isn't, what can maybe be the cause. So if you see, if we go to developer options again on our phone, all you need to do is select Profile GPU Rendering, and on the screen is bars, and then you'll see a nice little graph starting to form. So the green line that's drawn horizontally is actually how long your app should be taking to render its frames. So you can see I've got quite a few frames that are actually taking too long to render. And on the right-hand side of the slide, you'll see all the different reasons as to why something might be taking too long. So stuff like it's taking too long to draw, it's taking too long to upload to the GPU. So you can quickly identify where a problematic area might be in your app. So this tool is very useful for that kind of thing, identifying quickly where it is, where issues may be. But obviously it's not very descriptive as to how you can actually see those frames. So you need to use something typically like systrace or GL tracer to actually analyze what method is taking too long. But we'll get into some of those later. Cool. So the next set of tools that we're going to have a look at is memory analysis tools. So we'll actually help you find out where you actually put that object and what you did with it. The first tool that we're going to look at is a real-time monitor, memory monitor, of how much memory your app is actually using. So this is a real-time, when you plug your device into Android Studio, you'll see the graph starting to fall. And this is particularly useful for picking up quickly seeing if your app might have a memory leak. So it can also pick up things like if your app is slow because of maybe too many garbage collection events. So how do we actually use it? So to use Memory Monitor, go into Android Studio and select Android Monitor. You'll then see a whole bunch of different graphs are forming. So there's also a network graph that shows you how much data your app is actually using, which is also pretty cool. There's a CPU graph at the top that shows you how much CPU your app is using. And then the one that we're looking at now is the Memory Monitor tool. So this is as I'm going through my app, I can see the memory is starting to climb. So this is all very well, but if I think, okay, I might have a memory leak, how do I actually fix it? So this tool isn't really going to help you with that. It might just give you an indication that we might run. But the next tool that we're going to have a look at will show you how to fix it. So, okay, this is just a graph showing you what a memory leak might look like in Android Monitor. So you can see the memory is always increasing. It's never able to reclaim the memory. And then the actual, after the memory leak fix, we could see that it was able to reclaim memory and actually continue processing. So the next tool to look at is heap viewer. So this tool will actually show you what objects you have in memory, how many, and what are their sizes on the heap. So Eclipse Memory Analyzer has a few more features than this one in Android Studio, but they are always releasing updates, so I'm sure there will be one soon. But it's really good for identifying memory leaks and seeing how your app allocates and deallocates memory. So let's take a look at how you use it. Cool. So in your memory monitor that you were just in before, you select the little garbage truck, and then you select dump Java heap. So this takes a snapshot of exactly what's using memory at that point in time in your app. So once it's finished, this will take a couple of minutes to run, but once it's finished, you'll see a whole list of information about your app. So this typically shows you exactly how much memory is used by what objects. So if you group by your package name, you can go into see, okay, it's actually in my app, I'm interested in only my book dash app, and I want to see how many items are in memory of a certain thing. So you can see, if I look like book adapter, there's only one item in memory and how much space it's taking up. So typically what you would look out for here is if your activities, there's more than one in memory, that might not be such a great thing. So you can see my book info activity, I've got 2 instances of, so I might have a memory leak in this case. So yeah, that's heap viewer, and how do we actually avoid memory leaks in Android? So if there's one thing that you take away from this talk, it must be this. Okay? Never store context or a view in a static variable. And I mean never. This is an instant memory. So because of the way the Android lifecycle works, storing a context will in a static variable will hold reference to it throughout your whole app's lifecycle. So it's not a good idea to do this. The next thing you need to remember is try to avoid doing non-static inner classes within your activities or fragments. So this is also a memory leak. Say, for instance, you define an async task within your activity, that's a non-static class, and you reference your activity. So the async task will actually hold the implicit reference to the activity that's outside that is defined in, and that is another memory leak. So there's a lot of things that you can look at. I've done a whole blog post on how to avoid memory leaks. And the last one to remember is to always register your listeners and your unpause and undestroy methods. But there's a link to it at the end to go read more about memory leaks. But there's one thing, never store context in a static group. Cool. So the next one we're going to have a look at is compute analysis. So this is typically analyzing how long your code is taking to execute. So the first tool is systrace. This captures and displays times of how long your code took to run. You can either do it in code by saying trace.begin section, or you can do it by just clicking in a button in the Android device monitor. So once it's done processing, you'll get an HTML file out that's a report of exactly how much memory and how much time your code is taking to run. So this is useful for seeing if your app is dropping frames or what's actually slowing down your app's execution. So let's take a quick look at how to use it. So this is a trace that I've generated previously from running on my device, and you can see it indicates stuff like the little F is each frame that's being rendered. So the green ones indicate that it actually rendered in 60 milliseconds, and the yellow ones indicate that it was a little bit slow, and obviously if it gets red, then you should worry. So you can actually then go dive a bit deeper and get a bit more detail around what exactly was executing and why it took so long. The other thing you can have a look at in this tool is the alert section at the top. So Android will analyze your code and see exactly what you're doing and give you maybe some suggestions as to how you can improve it. So those little icons at the top will give you some information. So stuff like you should put this in the background grid, or you're not recycling your views. So stuff like that it'll highlight to you. Cool, so that's the stress. The next tool that we're going to have a look at is Overdraw. So this isn't an official Google product, but it's a website that you can go to, and you upload your app onto it, and it will give you an automated report of how long your app is taking to start up from a fresh install. So it's really useful and it's really easy to use. Just upload your APK. You can even do it through a graded task if you want. But what this produces is a nice little report that you can have a look at. I'm not sure if you can see from the back, but you can see how long it actually took to start your app up. So mine is taking 2 seconds. You can also see method counts, so you can avoid that ghastly dates method limit issue. You can also see exactly how long it's taking and what methods are taking the most time. So it'll profile your code without actually having to do any much work. So you can click on each item and drill down and see. You can even compare your app to other apps like Instagram, stuff like that. So that's Overdraw. Cool. So the next one that we're going to have a look at is saving the battery. So this is battery analysis tools. So battery is starting, but basically it runs as a separate tool. It's not within your Android Studio or anywhere else. It's a separate GitHub repo that you have to check out, and then you have to run a whole bunch of commands to install it, a little bit of a mission. But once it's up and running, you're good to go. So you can then just run, once you've got everything set up and running, you can just run an ADB bug report from your command line terminal with your device plugged in. So that'll take a few seconds, and then you'll get a bug report text file out. So once you've got that bug report, you can use it within this tool. So this tool will show you a bunch of cool things like what processes are being used, how long they're running, and that kind of thing. So we'll actually have a look at that. Cool, so I'm just going to show you how you actually start and run it. So it runs on your local machine. So when you start it up, it'll be running on port 999. So you'll get your battery started. You can then choose your file that you want to open up and inspect. And you can click submit. So once it's finished processing, you'll see a whole bunch of information. So you'll see exactly how long your app was awake for, how long your device was connected to the internet, how much data it transferred, and like the top power consuming app, what exactly was syncing, what traffic was being used, that kind of stuff. So we can go to the Historian 2 tab and you'll see a graph being displayed of your battery drain over time. So you can see from like 11 o'clock at night until about 7 o'clock in the morning, my battery wasn't being drained and my app was in doze mode. So it's in a power saving mode. And then as soon as I woke up and started actually using my phone, it went and almost died at 12 o'clock. So you'll see more information like what app is on top, what things are running, and stuff like that. And then if you want more detailed information, you can click on the legacy one, and this will show you exactly which app was running at that time and for how long it was running. You can also see things like what the Wi-Fi state was, what the mobile radio state was, and if any of your sensors were used. So, yeah, that's a very useful tool. The next section is the app stats. So you can select an app that's running on your device, and then you'll get a bit more information on it. So I've selected Facebook, and you can see Facebook is using a lot amount of data. It's running a lot of wake blocks. It's running a lot of services actually as well. So it could be a possible reason for my battery draining so much. Cool. So that's battery storing. So how do we avoid draining the user's battery? So there's a couple of things you need to keep in mind. You need to avoid wake blocks if possible. So don't wake the user's device up if you don't need to. You need to also defer operations that aren't supported. So stuff like your analytics or your logging, crash report logging, that shouldn't be done when the user has like 2% battery. You should do that when they're plugged in, charging, even if it's a couple of hours later. You don't really need that time-sensitive information to be going through it as quickly. The next thing to keep in mind is to batch up your operations to reduce the number of times you start up the mobile radio. So every time you start up the radio, it drains the battery quite a lot. So starting up the radio is quite an intense task, so you should avoid doing that. And you should probably do all the network operations that you want to do in a small batch, and then wait until the next time to turn it on. The next thing you can look at is the job scheduler API and the sync adapters. So within Android itself, they've built these APIs that you can use that already do a lot of this work for you. So the job scheduler API is only available from 21 and up, so Lollipop and up. But that you can say, okay, only run this job when the Wi-Fi is on and this user is charging the device. So it won't run things that aren't important. And it will also do the batching in that for you. So those are the two tools that you should probably have a look at using in your app if you can. And in conclusion, there's a lot of other tools available that you can use to analyze your performance. So the network monitor, we have a quick brief look at, CPU monitor, trace view, and allocation tracker, all other tools. So this list of the ones that I've given isn't exclusive, right? You should also use Overdraw to strip out unused code. So the more code you have that needs to compile, the longer your app will take to start up. So you should use stream resources and minify and label. And the next thing to remember is that your users matter. So you should be testing your app on a really low device and running with it for a day just to see how, if it drains the battery, if it actually starting up my activities really quickly, that kind of stuff. And the last thing to remember is that a fast app equals happy users, which equals good reviews, which equals happy devs. Cool. So I've got a bunch of links to everything that I've mentioned. You can check them out. And yeah, I'll put these slides up already on Twitter, so you can check them out there. So thank you. Any questions?
I just have a question on that. So, do you normally, you were talking about being proactive and reactive. How much time do you spend typically in your day addressing issues like this, where the other way would be to wait for feedback, get from your testers, and then go and look at some of these?
Okay, cool. So the question is how long do you wait, or how do you go about your process of picking out performance issues? So typically what I do is I actually run my app normally with Overdraw on. So the app might look funny, but if you're doing UI work, obviously you can turn it off. So when you're getting a feature, turn that debug GPU Overdraw on, turn on other things like the frame, the GPU rendering, and you'll get a lot more information. And while you're doing those features, you'll see actually, oh, this code might be taking a bit too long. So yeah, you can also, another option is to train up the testers to have a look at these tools and tell you, no, this thing is dropping frames. There's lots of things you can do to look at your performance. I would say it's good to include it in your story estimates, stuff like that.
I can build it into your deployment process as well. Thinking about the maintenance sort of going to manage to go and do this if it's above this flaggable.
You can do that. There are a couple of ways in which you can automate the process of actually doing it. So you can actually write automated espresso tests and then run those with profiling turned on. So it will tell you exactly, oh, the screen took too long to render, and you can fail your builds a lot more proactively than just letting it go through into production.
You can overhead to custom profiles and so on. So would you get false positive requirements to profile?
I mean, I don't think so. I haven't really seen a false positive before, so there might be a case that you do get that, but from what I've seen, everything that the tools tell you is generally right. Thanks so much, guys.